To set the tone for today, I'd like to introduce our keynote speaker. Few people have perspectives on data center infrastructure on a global scale quite like our keynote speaker, Adrian Maestro. As a VP of Global Energy Advisory at AECOM, Adrian works for the forefront of the industry, advising hyperscalers, governments, and enterprise operators on the complex strategic and physical challenges of scaling capacity at speed. Adrian, we would love to hear your insights. The floor is yours.
Great. Thank you, Julio. And thank you to DCI for giving me the opportunity to speak. And the biggest thank you to everybody who's made time in their busy diaries to tune into our event today. I'm going to talk you through a few perspectives around data centers. I'm probably going to start globally, look at some of the macro trends, and then I shall drill down to the UK. So if you bear with me a second, I'm just going to get my slides up, the traditional consulting perspective. And while I wait for my very old computer to start working, here we go. Okay, so I'm going to go through a bunch of slides that's got a lot of data, but I think just up front, I just want the key messages really that there's an enormous amount of investment that's being spent on data centers. Power demand is obviously one of the big hot topics, and I'll share a few thoughts about what we're seeing in the market around that. Grid congestion is obviously something that's a big challenge for the sector. The UK is a big market in its own right, but has its own challenges. The government here, I think, is doing a good job in trying to encourage the deployment of data centers in different parts of the UK, but there are some challenges around that. And then I just want to really finish on, just aside from power demand, there is a sustainability angle around water that I just want to make you all aware of. And also just communities. I think it's really important we understand how these data centers impact local communities and what you need to do to kind of make sure that they are engaged going forward. In terms of the spend, and I'm sure you will have seen lots of different numbers on this, but I think this is a good slide. You've got 4 companies, the big tech companies here, and they are forecast to spend in 2026 something like above $660 billion, which is a huge amount. It's the GDP of Argentina. It's probably about the same size of spend as the upstream oil and gas industry, which is made up of hundreds of companies. So really, really significant spend here and investment that's flowing into the sector, which is why we're talking a lot about it. At a global level, the power consumption of data centers is significant. This is IEA data, and you can see here on the left-hand side, actual consumption, which is the total absolute amount, the green bars here, about 400 terawatts hours and doubling by 2030. But the one that's probably slightly more resonant is if you look at the share of data centers of global electricity demand, it's tracking at round about 1.5%, but it's going to go over 3%. So quite a significant uptake. So you get an idea of the scale of data center power demands. It's always good to just keep these things in perspective. So on this chart here, you see global electricity demand growth by the different electrification vectors, and there's a lot of them. Electrification of heavy industry, think of cooling, air conditioning, etc. And you can see in the light green here data centers. And I think the important thing to remember is there are other sectors that are driving electrification that are going to consume much more power than data centers. But the reason why data centers have a disproportionate say in the conversation and in our minds is because the impact is so much more immediate. So just to kind of, again, just frame this a little bit. You will know that there's a lot of talk around congested power grids, and in the UK, we're looking to improve connection time. But this is some helpful data collected by JLL. And you can see here the different regions, Europe, Asia Pacific, and America, North America here. And you can see the connection time in hours. Amsterdam, which is really, really congested in terms of the grid is maxed out. You're talking about a 10-year connection time. London's tracking at about 7 years. And even if you look at other regions, Tokyo, again, about 10 years. And you look at North Virginia, so think of Data Center Alley, that dense collection of data centers, that's about 7 years. So we have a major issue there. And obviously that's partly because, or significantly because, we've got this grid, our transmission and distribution grid, that needs to be upgraded because there's all this pressure from different electrification sources, offshore wind, electric vehicle charging, and therefore a lot of these grids have to be upgraded. And on top of that, they have the pressure of these data centers being deployed. So that's the reason why you're getting these kind of significant timelines queuing for connection. This is a busy slide, which I'm going to break down for you. Just while you look at it, probably the most important thing is these are the different energy sources that are feeding data centers here. The ones at the top are current. The ones, as you work your way down, are more into the future. But obviously, power is a key focal point right now for conversation. I always say, just have a look at what's happening in the US, generally as an indicator of how other markets may evolve. So in the US, if you can't get a grid connection to power your data center, what a lot of the data center operators are doing is they're reverting to natural gas. So they'll install something, they call it islanded power. So basically you have a combined cycle gas turbine situated actually on the data center, fed by natural gas. It's quick to implement, quick to get out, given the pressure of construction time to build these data centers. From a kind of commercial perspective, it makes sense. The feedstock also is favorably priced, so the economics work well. But there's obviously an emissions issue there. And I think it's important just to remember, you know, the big tech companies have a fantastic reputation in terms of supporting low carbon sources. They're one of the biggest purchasers of power purchase agreements for low carbon. They have very ambitious net zero goals. But in spite of that, because of the pressure that they need to build these data centers, they're resorting to natural gas, which obviously has an emissions impact. If you look here, basically either as in the US, it's natural gas or low carbon solutions. And when I say low carbon, obviously solar, wind, battery energy storage solutions, and that some players are looking to actually combine all of those together. So you have the low carbon and the natural gas and maybe nuclear as well. Nuclear is an interesting one in the US where they can get access to nuclear power. So think of 3 Mile Island, one of the generators there is coming on back online. They're looking towards that. So nice, stable, baseload, clean, low carbon power. You're beginning to see, particularly in the US, applications of hydro and geothermal. The benefits of those technology, obviously clean and baseload, which is great. They're old technologies in terms of they've been around a long time. Their application to data center power is more nascent. But you're seeing some interesting plays there. Geothermal, think of Fervo, some of you who've tracked the fracking industry in the US. A lot of those engineers set up Fervo, and they're now providing geothermal power to one of the big tech companies for their data center. So you're seeing that grow. You'll hear an enormous amount of talk around small modular reactors, SMRs. There's a big expectation that they're going to be a valuable power source, you know, potentially kind of 1 gigawatt on site, or maybe less, could be 300 to 600 megawatts. But I guess the point around SMRs is they're not happening in the near term. The most ambitious deployment, I think, is likely to be in the early 2030s, and there are probably going to be challenges around SMRs as well, standardization, for example. And then I have to mention fusion. We as a firm do quite a lot of work in fusion already, fusion energy. And I think just to show you how desperate some of these operators are to source power, you've even got one example in the market. I think it's Helion that is got a power purchase agreement with at least Microsoft to provide fusion energy by 2028. I think that's extremely ambitious. I'm highly skeptical, but it illustrates the fact of how keen these operators of data centers are to source power. The last thing I just wanted to mention, just notice here, microgrid solution in Ireland. Interesting to note that there's a data center in Ireland already built by Pure Data Centers, where they're using a microgrid solution. So they're using stuff like combined cycle gas power on site, backup generators using diesel, and that can be switched to HVO. I think even the combined cycle gas turbine can be alternatively sourced using biomethane. So all this kind of innovation that we're seeing. And in terms of innovation, just also note, early days yet, but National Grid have a partnership with Emerald AI, and they're basically using AI as a way to manage the loads required by data centers in a more flexible manner. So I think you'll see the impact of innovation there helping address this demand for power. I'm going to shift gears now and talk a little bit more about the UK. And this basically is just a helpful top 10 data centers of the world. Just a caveat up front. There are a number of companies out there that do this ranking. They all have slightly different methodologies. This is sourced from the Visual Capitalist. Broadly, the mesh is still the same, but there may be some detail that's slightly different. But I think the key thing to get across is the US is by far the biggest market, unsurprisingly, about 4,000 data centers, about 40% of that market share. The UK is the second biggest, but significantly smaller with a 5% market share. And then you've got all these other countries. Sometimes China comes up as second as well. So, but it gives you an idea of the scale of the US, but also important other markets globally. Now, with regards to the UK, this will be very familiar to you. So that on the left-hand side here, lovely map of the UK. And unsurprisingly, of the 1.8-ish gigawatts of capacity of data centers in the UK, most of that, about a gigawatt, is in the London area, particularly West London, think of Slough, for example. You're beginning to see some of these data centers pop up in other parts of the country. And actually, I'm at an event in Scotland right now. And interestingly, there's a lot of talk about data centers being encouraged to redeploy to Scotland because you have obviously the land space, it's less dense, and you have access to a lot of this abundant low carbon energy, offshore wind primarily. And interesting to note as well, I think the head of NESO recently was quoted as saying, you know, we need to deploy more data centers in Scotland. I guess part of the challenge why that hasn't happened is because you already have the existing skills and infrastructure in London, access to fiber optic cable, etc. Even though it's congested, even though it's a difficult operating environment, you're close to your user demand, certainly for data centers that are focused on inference. And that's why you're still getting a lot of interest there. But maybe, potentially, if you think of data centers that are used for training, where they don't require to be so close to their centers of demand, potentially Scotland might be an interesting area to evolve. So let's see. In terms of the demand of data centers on the power system, this is a slightly dated Aurora Energy scenario, the one in the middle, the graph in the middle, but it illustrates the point. And I think you can see there, again, in absolute demand, terawatt hours, we're tracking just above 10 terawatt hours and rising, if you look at that mid-case scenario, by about 30. So nearly a tripling by 2035. But again, the percentages are interesting. So we're around about 4% of UK total power demand for data centers, potentially rising up to 12%. And on the right-hand side, again, just to illustrate the scale, Ofgem recently indicated that there's about 140 data center projects in the pipeline for connections and totaling something around 50 gigawatts. And you just need to bear in mind that peak power demand in the UK is 45 gigawatts. So again, just shows you how big this demand is for data centers. I mentioned in my opening remarks, I think the government has got the right idea and are doing the best they can to encourage the growth of these data centers. So there's the AI Growth Zone Initiative, which started off, I think it was with Culham, which again, I mentioned fusion. It's also Culham is the area where JET was located, which is a big pilot fusion plant. They obviously have access to a lot of power, so they've been encouraging. Culham was the first AI growth zone, and you've seen others deployed. Typically, the government is targeting sites that are brownfield, obviously easier to get permitting and planning permission because it's already the infrastructure is broadly in place. And you think of decommissioned coal-fired power stations, for example, transforming them into data centers. So there's a big push for that. We've seen quite significant investment or promises of investment by US tech companies in the last few months, particularly with the arrival of Trump for his state visit. But I think the big challenge that we're going to have in the UK, and this is not an easy nut to crack, is just the cost of power. So on the right-hand side, you can see a chart there, these industrial power prices, including and excluding tax. But if you look at the total amount, the UK is by far the highest there, tracking at about 26 pence per kilowatt hour. If you look at the left-hand end of the spectrum, Finland's tracking at just above 5 pence per kilowatt hour. So lots of abundant, cheap hydro. If you threw the US in there, I think they would probably be about 4 or 5 pence per kilowatt hour. So we have this intractable issue around high power prices. And you may argue the big tech companies have deep pockets and therefore, they can potentially live with that. Yeah, yes, possibly. But you also see a lot of investment flowing into the Nordics, into Spain, precisely because the power is cheaper and it's clean, low carbon. And I'm not quite sure how you're going to bring that industrial power price down. This kind of blends into this energy resilience, energy security issue we're seeing with the cost of living. There are a lot of baked-in costs into the power price, supporting the energy transition, network costs, etc. And with the fact that we've got our power prices coupled to gas doesn't help things either. So some challenges there from a kind of structural perspective, but I think one that will be key to make sure that we keep attracting investment into the UK. I just wanted to kind of just turn away from power. I know it's really important, but just to flag water, I think is going to be an important issue. And this surprised me, which was I didn't quite realize how water stressed the UK is. So the Environment Agency says we're going to have an expected shortfall in water demand of 5 billion litres a day by 2050. So currently, public water consumption is about 14 billion litres a day. So there's going to be a shortfall in 2050 of about a third. So important to know that we are actually water stressed, and that will vary from region to region in the UK. In terms of that water demand for data centers, obviously there's the cooling side, but important to note that the older data centers used evaporative cooling and quite prolific in their consumption of water. The new AI data centers use closed loop liquid cooling, which sees about a 70% reduction in water. So it's not using potable water and it's recycling that water, which is good. However, there is still an impact on water with the cooling, and there are the indirect uses of water. So if you're using a power generation source that generates steam to turn turbines, that's obviously going to have an impact on water demand. And as well, just in the process of rinsing the semiconductor chips, you have to use fresh potable water. And again, there's an impact there. So I think we just need to be cognizant of these different water uses, direct and indirect. And probably the bigger point I just wanted to make, and I have been doing my due diligence, speaking to lots of people in the water sector about this. So this is to date accurate. What I think is particularly galling is that there is not a lot of coordination between the planning authorities when they look at and approve data center applications and coordinating those applications with the water companies. So sometimes the water companies are surprised to see these different data centers being deployed in their jurisdiction because they've not been consulted in advance. And even in the UK water companies with their national water resource plans, to date, they are not taking into account the impact of data centers. And this chap, John Hernan from Thames Water, just a nice quote. I just highlight this bit here. We need to make sure that water is factored in at the earliest possible thinking, at the forefront, rather than an afterthought. And I think that's particularly true now going forward with these new AI data centers. Let me just flick on to communities. So I think on the left-hand side, a few snippets from the press, and you only have to Google BBC and water demand for data centers. You see a lot of hype is a strong word. I think it's an exaggeration, but there is definitely an issue there, which is you are seeing a lot of growing opposition to data centers. So it's building momentum, building up momentum in the US. Particularly in rural areas, which are now attracting a lot of interest from data center operators. I think in the UK, you're beginning to see some opposition rise against data centers. So I think it's really important that there's a very clear narrative that the data center industry articulates to communities to make them understand what the benefits of this sector are. And I think the sector generally has not done a great job historically, because I think they were in the background. In the last 2 years, data centers have come very much into the limelight, and they need to be able to articulate this narrative. There's on the employment side of data centers, important to remember that when you build these data centers, lots of employment opportunities. Once they're up and running, it's about 50 to 150 people that will be running that data center. But obviously, there will be supply chains built up around it. But important for the UK in terms of economic growth and AI leadership. But I think we need to engage communities much more. And an interesting Eon survey that came out, reach out to me afterwards if you want the source to that. But basically, the theme that came out was that you're more likely to get support from residential communities if, for example, you illustrate how heat from data centers can be recycled and diverted into residential district heating. So you're more likely to get support for that. I think I'm coming up to the end. I just want to say briefly, I'm not going to do the plug for the company, just to say we do a lot in data centers, from site due diligence right through to planning, design, up to the point of construction. And I would strongly urge you, have a look at the thought leadership that we've produced. We've done a lot on what we're seeing happening in the US, a lot that we see happening in the UK, and topics around data sovereignty, etc. Have a look, and please reach out to me if you're interested to discuss this more. So, Julie, I'm going to come out of the presentation share. I'm not sure if there are any questions or comments from the audience.
That's not a problem. Thank you very much for that. I really appreciate it. I actually do have a question myself, so I'm going to ask the first one so I can give time for everyone else to prepare themselves. So you noted that during your presentation that new AI data centers are going to cut freshwater usage by up to 70%. So outside of the cooling aspect, what is the single biggest physical change that this forces on building design as an aspect of data centers?
Yeah, I mean, just to be clear, so the liquid cooling is going to reduce traditional water consumption by 70%.
Yes.
And it doesn't need to use fresh water. It's recycling, potentially like wastewater. Yes. Exactly. I think in terms of just the overall design of data centers, I'll give you, and forgive me, I feel like as I'm advertising fusion energy, but just to give you an example of how these data centers can change the design because of innovation in technology, there is a use of a high temperature superconducting tape that's used in fusion. And there are applications potentially because of that, the very good thermal conductivity of this tape. There's a potential for using this in data centers instead of copper, for example, which will reduce the size potentially reduce the size and design of data centers. So there's lots of these examples of new technology that will change the way we design and shape data centers. So one simple example there.
Fantastic. We've got a question actually, so I'm going to read it out. So to what extent will the recent surge in energy costs impede GDP growth across the UK and Eurozone?
Wow. Well,
Yeah, big question.
yeah, and that's slightly outside the remit of this conversation, but it's a very pertinent point. Look, I think just generally for industry, if you think of heavy industry, which are big consumers of energy, cement producers, steel producers, etc., high power prices are not helpful. And one of the reasons why you see other regions more competitively priced, why you see investment going into the US, for example, where they have cheaper feedstocks, lower power prices, albeit in some regions those power prices are beginning to go up precisely because of data centers. You'll see investment flow in other regions where they have access to cheaper power. So I think it's a very broad question. I think the most important thing about attracting investment in the UK from an industry perspective is regulatory stability. So you need to have a government that doesn't mess around with the tax regime, that has a very clear agenda. But it would also be helpful if we had lower energy prices, because I think that would
Make it
attract.
cheaper, I agree.
Yeah, it would. But it's not an easy thing to fix.
I know.
And particularly with the conflict in the Middle East, you're beginning to see the implications of this as well. It's a good question.
I agree. It is a good question. There's one more question I've got. It's quite an interesting one, actually. So how do you assess the quantum opportunity for AI data centers? How could it force, for example, a change in investment strategy regarding power requirements, long to medium term?
So excellent question. So I'm interpreting that as the advent of quantum computing.
Yes.
Yeah. So obviously, if quantum computing takes off, and that's an if, I'm not saying a big
Hopefully
or small,
it does,
it's an
but
if, right? If it does, there would be implications around the energy efficiency of those data centers, so arguably less energy required for quantum computing, and therefore less demand on power consumption. And we had this debate or this discussion around this when DeepSeek came out at far less use of power, and what the implications of that power demand will be. Obviously, it's good for the system, arguably, if new technologies come out that require less energy, which is great. There is a challenge potentially that we're designing a system that is built for higher energy usage, and you might say, well, if quantum comes on, these data centers use less energy, you suddenly got a surplus of power. Yeah. And actually, I was at an event and a panel yesterday. We talked about this, and I think the argument is you're seeing so many of these electrification vectors that I alluded to earlier that actually we're still going to need that surplus of power to deal with these other vectors. So while data center demand might go down for power, there'll be other vectors that will need more power. So I think the system, we still should have enough power to deal with that.
Yeah. And would you also say that the aggressive pursuit towards quantum itself could cause a more power demand? So by the time we reach quantum, there could be a massive deficit of required power.
Yeah, maybe. I'm not sure. I'm not even going to pretend to answer that question, but I think it's a good one to have an offline discussion about.
For sure. I've got one more question on my side. So going back to the UK industrial prices. So UK industrial power prices, they're nearly doubled out of the European average. So power availability, that's basically our biggest bottleneck. These uncompetitive costs, they are basically a threat to the UK growth. How could you foresee a way to circumnavigate it, if you will?
Yeah, so there's a data center answer, and then there's a broader industrial answer. I think the data center answer is, I think you need to also just remember that while we have high power prices, data centers are still being built here, right? And there's a reason for that, because the UK is still an attractive environment. We're right on the doorstep of the UK. We have lots of fiber access, lots of skills and capabilities. So there is an argument there that power prices are a factor, but there are other things that will drive data center operators to build in the UK. So don't think it's just going to stymie investment. That's kind of point one. I guess the broader point, which again I was alluding to briefly, in terms of if we're going to want to attract more international investment and support heavy industry and broader industrial demand, the key will be decoupling gas from power prices, because gas sets the price in the UK for power. So it doesn't matter
Yes.
how much renewables we have, even with Clean Power 2030, which is 95% low carbon power generation system that the government's pushing, there's 5% that's still being generated by gas as a kind of a backup base load. And the problem is, while gas is linked to electricity prices and effectively setting that electricity price, until we decouple those two, we're not going to get the benefits of a completely renewable power system. And that is a technical challenge that the government's trying to address, and we are making slow progress on that.
Hopefully we can be a bit faster as well. That's perfect. Thank you so much. I really appreciate it. We got have one more question, but unfortunately we got not too much time. So we're going to just proceed with the next one. Adrian, thank you so much for your time.
Thank you, Junior. Have a great day, everybody. Thanks. Bye.
Thanks so much.